Hello, everyone. Welcome back. As I promised, this is the advanced session of rotation in which we are going to explore different angles other than 90 degrees. And I said that may be helpful to mathematicians, engineers, or scientists in general. So this would be a bonus session. So it's really for advanced math. So rotation, bonus. And to show you where the equations we'll be using are coming from, so you can derive them on your own. If, for example, you forgot, was that a plus or a minus? Was that a sine or a cosine? I'll try to make it easy for you to see. So let's look at any line in the first quadrant, just for simplicity, so everything is positive. But it applies to anything really you have. So let's suppose again, it works. We are going to apply it for points, or maybe I'm going to skip points. We'll do like figures right away. So if I have a line here, and let's call that, for example, OP. If that point is P, and I call that or call that okay, OP, and let's say it has a length L. Okay, and it makes an angle phi with the x-axis. As I told you, for engineers and mathematicians, we refer to counterclockwise rotation as positive. So that's why we are going to rotate counterclockwise, but we'll see what happens if we rotate clockwise. So again, it's not to scale, so these two lines will not be exactly the same length. I rotate to P prime through an angle theta. Okay. Notice the length didn't change because I took the point and just rotated using a compass. So the length is the same as the radius of that particular circle. Now, the coordinates of P, which are X and Y, the coordinates of P prime, let's call them X prime and Y prime. We know from trig that X is L cosine phi and Y is L sine phi, right? This is simple. Adjacent is cosine, X, opposite or is the sine or Y. But what about the coordinates of P prime? So this is point P. For P prime, I can say that X prime is cosine theta plus phi. I'm sorry, L cosine. And Y prime is L sine theta plus phi. And now I have to go back to my knowledge of trig, which I hope you all master. How do we expand cosine alpha plus beta? It's cosine theta cosine phi minus sine theta sine phi. No, notice if this is plus, this is a minus and backwards. And if you forget, is it this or that? There is a very easy way to do it. Try the negative. Let's say cosine theta minus theta. Okay? Let's make that negative theta, not phi. So theta minus theta is cosine 0, and cosine 0 is 1. Let's see if we do theta and theta. So that would be cosine theta, cosine theta. Notice that was a minus. So I would say plus sine theta, and you get sine square plus cosine square, which we know is 1. So it's very easy to check. Or you make that pi over 4 and pi over 4. Why? Because I know that cosine of pi over 2 is 0. So cosine square pi over 4 minus sine square pi over 4. I know that sine pi over 4 is the same as cosine pi over 4. Both of them are root 2 over 2. So you are subtracting the same value from itself. You get 0, and cosine 90 is 0. So it's so easy to, if you forget, to just use numbers that, or angles that makes life easy for you. Make an angle of 0 or a 90 degrees, since you know sine 90 and cosine 90, sine 0 and cosine 0. Anyway, now I'm going to elaborate on that. I know that L cosine phi is x. So that becomes x cosine theta minus L sine phi is y. So minus y sine theta. This is x prime. Let's look at y prime. I know that y prime is L sine theta plus phi. So I'm going to say y prime equals L times, and then I'm going to expand that. Sine theta cosine phi plus, not minus, cosine theta sine phi. Again, L cosine is x. So you get x sine theta plus, and L sine phi is y. So y cosine theta. If you take cosine, negative sine, sine, cosine, that becomes a matrix of rotation, counterclockwise rotation. We are not going to talk about that. Maybe when we elaborate more on matrices, we can show you that we can do this quicker. And notice, we said this is counterclockwise rotation. It turns out if you solve for x and y in terms of x prime and y prime, or when you learn how to find the inverse of a matrix later in math, we are going to say that for clockwise rotation, x prime would be x cosine theta plus y sine theta, and y prime would be negative x sine theta plus y cosine theta. So we switch the sign of these two guys, but everything stays the same. Cosine, sine, cosine, sine, cosine is the same. And that's it. So remember what we did last time for rotation of 90 degrees? So if I'm rotating counterclockwise 90 degrees, do you remember what happened? We switch the x with the y, but we change the first sign, the sign of the new x, which was the original y. I don't want to confuse you with x and y, like who's on first and what's on second, right? So what we are going to do is to say, just for 90 degrees, cosine 90 is 0, so that becomes 0, and sine 90 is 1, so you get the x becomes negative y. Yeah, we change the sign. Remember, we switch the x with the y and we change the sign, so we get the negative y. Whatever is y now would become a negative x, so to speak. And same thing here, the cosine is 0, so you get y prime equals x if we are rotating counterclockwise. If we are rotating clockwise, it's the other way around. Anyway, you don't have to worry about that since you already have the equation. Okay, cosine, negative sine. And you can remember that. You say, if we rotate counterclockwise, the x gets shorter. That's why you subtract. But the y gets higher. That's why you add. if you are rotating counterclockwise. So that's a quick reminder for you, okay? But again, that's, or you can derive it like I did, which take longer. But again, if you rotate clockwise, you see the x increases and the y gets shorter, so you have the negative in the y clockwise. Okay, having said that, let's keep this on the side so we can see it and start like we did before with a straight line. So let's say rotate again. Please remember that these transformation works for points. So if you give me a point and you tell me rotate it counterclockwise, I'm going to use these equations. Rotate the point clockwise, I'm going to use that rotation. But if that's an equation of a line or a parabola or hyperbola or anything, I'm going to use the backwards. Remember from last time? We are going, if it's a clockwise, I'm going to rotate counterclockwise. If it's counterclockwise, I'm going to rotate clockwise, the equation itself. Again, I know it may be a little confusing, but for now, take my word for it, and later you will learn. Remember, go back to give you like something similar. Remember when we were talking about graphing or graph transformations? If I have a point x equals 3 and I tell you move it to the right 3 units, wouldn't you add 3 and make the 3 6? But what if I have y equals x and I say move the graph, this line, 3 units to the right? You would say x minus 3, not plus 3. Similar here. Okay? So it's the same way that we are moving. Think of it as we are moving the coordinates, not the points. So we are doing it backwards. Okay, let's take an example and see if it makes sense. Let's say rotate, and let's make a line y equals 2x minus 3, and I want to rotate it 30 degrees clockwise about a point, not about the origin again, about a point, let's say 2 and 4. How would I do that? Notice, there are always 3 steps. Step number 1, I'm going to add, instead of subtracting these to the x and the y, remember? As we did with points, the opposite. So the y becomes y plus 4 because I'm going to add the coordinates. Y plus 4 equals 2 times x plus 2 minus 3. So I get y equals 2x, and then I have negative 4 and negative 3 and positive 4, so minus 3, which incidentally is the same equation. I picked a point, this thing happens a lot. I didn't plan it, but it turns out to be so don't get confused. It's not always so. If we made that a 3, for example, not a 4, that would be a 3, and that would have been minus 4 instead of minus 3, so it would be different. But we were lucky it happened like that. Step number 2, notice I'm rotating clockwise. So I'm going to apply the counterclockwise equations where we had the x prime, so to speak, right, was x cosine theta, and theta here is 30 degrees, and cosine 30 degrees is root 3 over 2. So it's root 3 over 2x. And if it's a counterclockwise, remember, the x decreases, so minus sine 30, which is 1/2 y. And how about the y prime? I switch the coefficients and I make them both positive because now the y increases, gets longer. So I'm going to say 1/2 x plus root 3 over 2y. That's it. But now I have to apply it to the equation. So this equation, the y prime, which replaces the y, becomes 1/2 x plus root 3 over 2y equals 2 times the x becomes root 3 over 2x minus 1/2 y minus 3. It's not that bad. It looks hard, but uh, it's really not. The 2 with the 2's here, you can cancel that by distributing the 2. And I'm going to move the y on the left-hand side. So this would be negative y because notice 2 times negative 1/2 is negative 1. So when I move it to the other side, it becomes y. So I get root 3 over 2 plus 1y equals, oh, I'm sorry, plus 1y equals. And then I'm going to move the x to that side. So that would be root 3 minus 1/2 x, and then I have minus 3. Right there, I can use my calculator and see if that makes sense. Remember, the angle was 30 degrees, meaning the slope of this line should decrease by 30 degrees. So that's sometimes you don't have to wait till the end to check your work. So maybe we can have something. I think I have it still in degrees. Yes. Okay. So the slope of this is inverse tan 2, right? 63,435 degrees. How about this? Notice that if I divide the whole equation, you will tell me, but you still didn't add and sub. Yeah, I know, but we are going to do that. Do you think? Do you think we should finish first? Hmm. It won't affect the slope, right? Because that's a constant. So let's find the slope here. Inverse tan. The numerator is the square root of 3 minus 1/2 divided by, because I'm going to divide the whole equation by that, divided by, open parentheses, square root of 3 over 2 plus 1, close. Yeah, exactly. 33.4. It decreased by 30 degrees. The angle was 63. I rotated clockwise 30 degrees, so I should be fine. The last step, which is step number 3, I'm going to say, maybe I'm going to use a common denominator. So root 3 plus 2 over 2. And this would be y minus 4, right? Because I'm going to subtract it now. Notice we added that in the beginning. Equals. And again, this would be 2 root 3 minus 1 over 2x minus 2 minus 3. So I can multiply the whole equation by 2. So this by 2, and I don't forget to make that is 6. So I will get root 3 plus 2y. And then I'm going to move everything to the other side, equals 2 root 3 minus 1x. I have negative 4 root 3 would move there as positive 4 root 3. And I have negative 4 root 3. The root 3 cancel each other? Is that true? Negative 4 root 3. So it will become positive 4 root 3. And here I have negative 4 root 3. Yeah, they cancel each other. How about the 2? I have negative 8. It will go there as positive 8. Plus 2 is positive 10. Minus 6 is positive 4. So it would be a nice equation. Again, usually if you want to write it, you can say y equals 2 root 3 minus 1 over root 3 plus 2, x plus 4 over root 3 plus 2. And if you don't want radicals in the denominator, then you would multiply top and bottom by root 3 minus 2 over root 3 minus 2. Again, it's a long word. The denominator would be negative 1 because root 3 minus 2 plus 2 times root 3 minus 2 would be root 3 square minus 2 square. So 3 minus 4 is negative 1. So you will get 1 minus 2 root 3 because it's a negative 1x. And this would be negative 1, so minus 4 times root 3 minus 2. I hope I did the math correctly. No, I didn't. Because that cannot be right. Let's see. Negative 4, they cancel. And then negative 8 would be positive 8, 10 minus 6 is 4. So far, so good. But when I divided this by that, oh yeah, of course not. I did this incorrectly. I'm sorry. I multiply these two. I divided by negative 1, so that would be 1 minus, I forgot to multiply that by root 3 minus 2. I multiplied it here, but not there. So this y would become, first of all, for the constants, I have negative 2 root 3 by root 3 is negative 6, minus 2 is negative 8, and then I have 1 root 5 root 3 minus 8x minus 4 root 3 minus 2. Let's check and see if this is the same. The slope is still the same. So inverse tan of 5 square root of 3 minus 8. Yeah, 33,433. I forgot to multiply that. I apologize. And that would be it. So that's the equation. You could have left it like that or like this, but we see here that the slope is exactly, I rotated 30 degrees, and this is how you do it. You see, very concise, other than if you pick points. So let's take another example. Last time we did an ellipse. So let's take something else. Let's say rotate y equals x plus 1 square. So we make it a parabola minus 4 and rotate it 45 degrees. This one was clockwise, so counterclockwise. And just for simplicity, let's make it around the origin. There is no reason to keep adding and subtracting. So, okay, about the origin. So we start 3 steps. Step number 1, canceled, because I'm going to add 0 and 0 to the x. Step number 3, canceled, because I'm going to subtract 0 and 0 from the x and y. So all what I have to do now is to do step number 2. Step 2. Notice this is counterclockwise, so I'm going to use the equations of the clockwise. So I'm going to say my x prime, which are these, x prime and y prime, and I'm going to change. So instead of working with x and y and end up with an equation in x prime and y prime, I'm going to assume these are the x prime and y prime, and I'm going to get x and y. So x prime would be x cosine theta plus, because it's clockwise now, not counterclockwise. So when you turn clockwise, the x extends and the y shrinks. So plus y sine theta, and the y prime would be negative x sine theta plus y cosine theta. Sine theta equals cosine theta equals root 2 over 2. So 45 is easy. Everything is root 2 over 2. So the y, I'm going to write it negative root 2 over 2x plus root 2 over 2y. Because I'm going to replace the y with that, and everything here is root 2 over 2 equals x, which is root 2 over 2x plus root 2 over 2y plus 1, quantity square minus 4. And you say, oh my God, this is terrible. No, it's not terrible. When you square these, you get the square of the first plus the square of the second plus the square of the third plus twice the first times the second plus twice the first times the third plus twice the second times the third. So it's not that bad. Instead of having 3 terms, now we have 6. So I'm going to leave the left-hand side. There is no reason to rewrite them, but let's square that. The square of, notice that when you square that, you get 1/2. So x squared over 2. When you square that, you get y squared over 2. When you square that, you get 1. So far, so easy. Twice the first times the second. The first times the second, notice the numerator is 2, the denominator is 4, so it's 1/2. But you multiply by 2, so you get 1, which means xy. When you multiply these two, notice twice the first times the second, the 2 and the 2 cancel, and you get plus root 2x. Twice the second and the third, plus root 2y minus 4. So, do you see? It wasn't that bad. It really doesn't take that long. Like we did in the previous problem, since everything here has halves, we can get rid by multiplying everything by 2. So that becomes a 2. Here I get a 2. Here I get a 2. Here I get a 2. Good. Oh my God. Here I get an 8. And finally, I'm going to move everything to one side. So I have x squared plus y squared plus 2xy. And then I look at the x's. I have 2 root 2 and negative root 2. When I move it to this side, it becomes positive root 2. So I get 3 root 2x. I have 2 root 2y. This is a root y. When I move it, it becomes negative. So I end up with a single root 2y. And have a 2 minus 8 is negative 6 equals 0. And that's the equation of a parabola that rotates 45 degrees counterclockwise. Instead of being vertical, I rotate it, and its axis now makes 45 degrees. And that's why you see the xy. Every time there is an xy, it means it's a rotation. And maybe it's not time now to discuss. So how do I know if that's a parabola or a hyperbola or an ellipse? Because remember, when they were originally, the y wasn't squared. Only the x was squared. Here, both are squared, and I have that. Okay? But you see the twice and e squared. Again, there is an easy way to check and see. Maybe we'll discuss it later in more advanced sessions. But this is it for today. And you saw now that really the rotation of 90 degrees is a special case when you make theta equals 90. So the cosines vanish and the sine become 1, and you are substituting x prime is y and y prime is x, is negative x, And if it's a clockwise, it would be x prime is negative y and y prime is x. That's all. So it's a special case of the genetic equation that we develop right now. I didn't tell you how we got the clockwise from the counterclockwise because that requires more advanced matrices, and I intend to do matrices soon, hopefully. Thanks for your time. Again, if you have any questions or any comments, please let me know by writing to me in the comments section. Otherwise, I wish you all the best and hope to see you soon.